Okay, so in this video, I am going to go over the chapter 1 and 2 exam solution, and I'm going to first go over the no calculator part. So in the no calculator part, the first question asks you to find two limits. So EKS is limits and continuity. And the first problem asks you to find the limit as x approaches negative 3 of x squared minus 1. So if we plug in just negative 3, okay, into this function, you will find that you get 0 over 0, which is indeterminate. So that means you don't really know what the limit is using just substitution. So we have to use a different method. So one method, if you can see, it looks like 6 and 9 share common factors. This is a quadratic that maybe we can factor out. You want to use factoring and simplifying to possibly find this limit. So let's go ahead and do that. So the limit as x approaches negative 3 of x squared plus x minus 6 over x squared minus 9 is equal to the limit as x approaches negative 3 of, you can factor this top part out into x plus 3 times x minus 2. And you can factor this denominator to x plus 3 times x minus 3. Okay, so if you're not really great at factoring out quadratic equations, this may be something you want to practice on your own because it is a useful skill when finding limits. So as you can see, there's an x plus 3 on the top and on the bottom, so it cancels out. So now we're left with the limit as x approaches negative 3 of x minus 2 over x minus 3. We can now substitute our negative 3, and we will not end up with an indeterminate function. We instead end up with negative 5 over negative 6, which is 5 over 6. So there's our limit. Okay. The next one was asking you to find the limit as x approaches infinity of the square root of 9x squared minus 3x plus 1 over 4x squared minus 1. This one you could simply analyze by using logic. As you can see, the top part's getting square rooted. Okay, so numerator is under a square root or a radical. Okay, whoops. And then the denominator is getting squared. Is getting squared. So as you can see, because the denominator has a higher power, higher degree. I mean, this is being square rooted, so it's not increasing at a rate that's as fast as getting squared. So your denominator grows more quickly than your numerator. So meaning that as x approaches infinity, you're going to have something that looks like the square root of 9x squared minus 3x plus 1 over infinity, because the bottom is approaching infinity just so much more quickly. Remember, again, when your denominator approaches infinity, essentially you're dividing by infinity, a really, really big number. You're dividing $1 amongst infinite people. So each person gets essentially 0. Okay? So the limit of that second function as x approaches infinity is 0. Okay, the next part was asking you a question about this function f of x, which is equal to x squared plus 3x minus 10 over x squared minus 4. And it was asking you which of these statements is true. 1, the limit as x approaches 2 of f of x exists. 2, f of 2 exists. And 3, f of x is continuous at x equals 2. So you had to determine which of these statements are true. Okay? So let's test the first statement. The limit as x approaches 2 of x squared plus 3x minus 10 over x squared minus 4. So as you can see, if we plug in 2 into our function, over 2 squared minus 4 here, we would get 4 plus 6 minus 10 over 4 minus 4, which is 0 over 0. Again, this is indeterminate. It doesn't tell you the limit, so we have to find another way. So we can maybe factor this top and bottom into x plus 5 times x minus 2. Again, if you're not very good at factoring, this is something you may want to practice. And the bottom factors out into x plus 2 times x minus 2. We can cancel out the x minus 2's. We are left with the limit as x approaches 2 of x plus 5 over x plus 2. Now we can substitute 2 in for x, and we get 7 over 4. So we do have a limit, and it is 7 over 4. So the first statement is true. Let's test the second statement. Does f of 2 exist? So f of 2 is just equal to 2 squared plus 3x, so 3 times 2, minus 10 all over 2 squared minus 4. Well, as we saw already, this is 0 over 0, which is a whole. So f of 2 does not exist. So the second statement is false. The third statement is obviously false because since f of 2 does not exist, that's one of the conditions of continuity, is there's a value at that x value. There's a y value at that x value, and here there is not. So since f of 2 does not exist, f of x is not continuous at x equals 2. So the third statement is also false. So the only true statement was the first one. Okay, so that was the limits and continuity portion. The second portion of the no calculator part was the EKS functions and graphs. And you were given a velocity graph to analyze. Now, many of you confuse the velocity graph with a position graph. But you want to be careful. Position graph tells you what position you are at a certain time. Velocity graph tells you your speed at a certain time. So very different. So here was your velocity graph. Here's t. Here's v. We've got 1, 2, 3, 4. Got 1, 2, 3, negative 4. And then we went all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then your graph looked something like this. And then you went up to 2. At 3. And then you slowed down all the way here 5. Okay? And then you kept going till you were at 6, negative 2. And then you were constant speed for a while. And then you just increased in speed, and then you stopped at 8. Okay? So this is what your velocity graph looked like. There were some, and oh, by the way, you were given that at t equals 0, your position of object is 5. So you didn't start at 0, 0. You started at 0, 5 on your position graph. Okay? So this is something many of you missed as well. So I want to make sure you're aware of where your starting point is. Okay? So you were asked a series of questions. about this graph. The first one was, when is the object at rest? So clearly the object is at rest when v of t, your velocity, is 0 because you're not moving, there's no rate of change. So your velocity is 0 at 2 points, here at 5 and here at 8. So this one was pretty simple. Okay? And then the next question was, what is the position of the object at t equals 5? Okay, so your velocity here, and you want to know the position. So again, position is the area under the velocity curve. So you were supposed to find the area under this whole section. So this rectangle was an area of 1. This triangle was an area of 1 times 2 divided by 2, which is also 1. This rectangle right here had an area of 3. This triangle had the area of 1/2. 1, 2, 3. Sorry, this was supposed to be 1, 2, 3. So the area is actually 1/2 times 2 times 1 times 3, which is 3/2. My apologies. Okay, so then the area under the curve was 1, 3/2, 3, and 1/2. Plus, okay, remember at 0, you started out at 5. So you add all those up together. So 1 plus 3/2 plus 3 plus 1/2 plus 5. And that's where your position is at t equals 5. So if we add it up, this becomes 1 plus 3 is 4, 4 plus 5 is 10, 10 plus 2 is 12. Sorry, no, 9 plus 2 is 11, not 12. Okay, so you are at 11. Okay, the third question was the total distance traveled from 0 to 8. Okay, so you already know the distance you traveled from 0 to 5. That's just what we had to find out. But now you got to find out the distance you traveled from 5 to 8. Again, this is area under the curve, and it's a positive area because distance is positive. Okay, so we're not taking into account your direction. We just want to know the distance. So if we find the area of this triangle, it's 1/2 base times height, which is 1/2 times 3 times 1. Same thing with this triangle, I believe. 1/2 base times height. And this rectangle is 1 times 3, which is 3. So we have 3/2 plus 3/2 plus 3. So we got to add 3/2 plus 3/2 plus 3 to the distance we already found from 0 to 5. We add all that up, we get 16 units. Wait, hold on. 6 over 2 is 3 plus 3 is 6 plus, actually it's 17 units. 17. Okay? So all you had to do was find the area under the curve, add it all up, and then don't forget that your original position was at 5. And then the last question was pretty simple. Is the object slowing down or speeding up at t equals 2? Speeding up or slowing down? That was pretty simple. If you look at t equals 2, as you can see, my velocity is increasing, so my object is speeding up. Okay. So that's it for the no calculator portion. In the next video, I'll go over the solutions for the calculator portion.